Here's the Hammond M-143 organ, and I thought I might be able to play this today, but it's going to need some more lubrication on the generator. The oil's going to need to get in there, and I hooked it up. I got the electronics chassis here. I brought that in here. Then I hooked up the power to the motor part of it with some alligator clip leads, and I thought I'd just check out and see how the mechanism started up. This morning I put Hammond organ generator oil into it, and I thought it might start up, but it didn't. It was seized up really good. Here's the starting motor back here, you can see, and it connects to this really long shaft, and it's got main bearings on it. It's not really a crankshaft, but it's like in a car where you got a long shaft supported by bearings, and all these are the little tone wheels that produce the sound. The way it produces a sound, you can see it's got little teeth on it. Those little teeth pass by these coils, and when the tooth passes by, it induces current in the coil, and then when it goes away, that's how you get the different frequencies, by the number of teeth on there, because it generates an alternating current by the metal disc passing by and going away from the little coils. And ones for bass frequencies like this one just have one tooth on it, and ones for higher frequencies like that one have a lot of teeth on them. Well, all of these things have to turn. They all have bearings. I don't remember how many tone wheels total there are on one of these, but it's a lot. Each one of them has a bearing. And let's see if I can turn this here. This shaft here is the main. Get the flashlight back on. That's the main shaft in it, and it's broken up into segments, so that it's not one rigid shaft. It's in several segments, and right here, let's see if we can see it here. Right here is a spring coupling that provides some isolation between the segments, and it allows for like some inertia in the mechanism, or it'll allow, for instance, this section will, if it's freed up, will start turning, but if this section is seized here, it'll just cause the entire system to bind up. So these ones in the middle here were really seized, and see, now I can actually turn them. You can see they're all turning. If I turn here, let me get the motor. We'll get the motor shaft from the outside here, and see they're starting to turn pretty good. But you can see I'm turning the main motor shaft here. You can notice they're turning here. But when I got the motor going, the motor finally did turn the entire mechanism over, but it started squealing like there was bearings that didn't have any oil. So what I had to do in order to get it unseized is use LPS2. Now, I know they say you shouldn't use anything but Hammond organ generator oil on it, but I've used this and it seems to work pretty good. I've only used this though when I've had a seized mechanism. And I just applied LPS2 to the bearings on the main shaft and some of the tone generator bearings, and that loosened it up. I don't know that just the application of Hammond organ generator oil would have got it all freed up. Maybe over a period of many weeks, or maybe not. So I thought I'd just go for LPS2. But there are some, which is a penetrating oil. There's some types of penetrating oil I don't want to use in this, and there are some types that get gummy. They're good for breaking things loose, but they leave a gummy residue. This seems to be pretty non-gummy and non-destructive. So I was able to get the mechanism freed up with LPS2. I'm going to plug in the alligator clip cord here, and let's see if I can start up the mechanism. It might start squealing, so I might have to stop it. Yeah, see, it's squealing. It's all turning, but it's squealing. So I'm gonna have to just let it sit, and hopefully that Hammond organ generator oil will get into the bearings, and because I put some additional into the oil cups, so hopefully that'll get everything lubricated up the way it should be. At least I was able to get it unseized. Dog decided to come by.